the beginning of our new unit, which is trigonometry. So you want to print these out. If you don't have a printer, that's totally fine. Just do the best you can on lined paper. So on this page here, we've outlined a couple of the things that we're going to be touching on. So today our goal is to cover these first two bullet points. We're going to be reviewing square roots and Pythagorean theorem. Then we are actually going to skip down and do the defining of trig ratios. So this is what we're going to be doing day 2. We're going to spend actually 2 entire days. So day 3 and 4 are going to be spent solving. And then at the end of the unit, day 5, we'll be doing our special triangles. The tentative test date for this unit is May 13th. Okay, this will most likely be our final unit for the year. So let's get started. Simplifying and rationalizing square roots is one of those key background knowledges that if we review how to do it, it'll just make your life a lot easier because this is an area that you already know and you don't have to get stuck on every time. So as a review, when you are simplifying radicals, you are splitting it into factors that are a perfect square. So if I were to list factors of 45, okay, factors of 45, I'm saying what multiplies to 45. So if I've got my calculator and maybe I don't know my factors, the first one is always 1. So 1 and 45. Okay. Then I would test 2. So I do 45 divided by 2, which gives me 22.5. So 2 is not a factor because I need whole numbers. Then I would do 45 divided by 3, which is 15. So another set of factors are 3 and 15. 45 divided by 4 gives me another decimal. 45 divided by 5 gives me 9. 45 divided by 10 gives me a decimal. 45 divided by 11 gives me another decimal. Let's see what's next. 12, another decimal, and then at that point, I'm practically out of options because I'm going to start repeating things. So these are my factors, and what you want to do is you want to look and see which of those factors has the largest perfect square. Okay, so ones that you can take a square root of. So here I could take the square root of 1, which is 1, but that doesn't really help me because I still have a 45. 3 and 15 are not perfect squares, so that one's like totally not an option. And then 5 and 9. 9 is a perfect square. The square root of 9 is 3, positive or negative 3. So that's the option I want to go with. So I'm going to separate this, and I'm going to say the square root of 9 times the square root of 5. The square root of 9 is positive or negative 3, and the square root of 5 is something. Okay, it's not a perfect square, so I can keep it under the radical. This is your final answer. Now remember, if you have a nice calculator that has this button on it, where it's got like 2 arrows here, if you click that button, it's going to convert into a decimal, and you're going to want to make sure that you know how to do that. Okay. Another option, if you do not have a handheld calculator at home, what you can do for calculator access, is go to desmos.com, and you're going to look for their scientific calculator. That website is completely free, and I'll actually be doing a demo on how to use that at a later date. Going back to rationalizing radicals. At this point, I would like you to pause the video and complete the other examples by yourself. And I'm now going to quickly go through how to do problems 2, 3, and 4 because they're all very similar. So factors of 63 would be the square root of 9 and the square root of 7. Square root of 9, again, is positive or negative 3. Square root of 7 can't be done, so it stays the square root of 7. If I were to convert that to a decimal, I would get 7.9. Okay, 24 can be split into the square root of 4 times the square root of 6, which would be positive or negative 2 times the square root of 6. So these should actually all have positive, negative in front of them. Okay, and then 2 square root of 6 can be simplified to 4.9. Finally, we have 96. 96, honestly, it took me a while. I had to do that factor list, but I came up with the square root of 16 and the square root of 6. Square root of 16 is positive or negative 4. And if you convert that into a decimal, you get 9.8. Our next type of radicals that we want to review are called rationalizing. So if you think back to way back when, we do not like this. Don't like that. And the that I'm talking about is the radical in the denominator. That is like a huge no-no. So to get rid of it, we multiply by a very special form of 1 to get rid of it. And the form of 1 is you take the denominator and you put it into a fraction. Then you multiply straight across. So 1 times the square root of 3 would just be the square root of 3. Square root of 3 times square root of 3 would give you square root of 9. Well, square root of 3 cannot be simplified, but the square root of 9 is positive or negative 3. And you're done. Now pause the video and complete 6, 7, and 8. Let's check your work. Special form of 1. And I'm getting that because that's exactly what's in the denominator. Square root of 6, square root of 36. So you get the square root of 6 over positive or negative 6. Okay, second two, numerator has nothing to do with rationalizing. It's all about the denominator. So I do square root of 7 over square root of 7. Square root of 35. Oops. Over the square root of 49. The square root of 35 actually can't be simplified. And our last one, we get the square root of 6 times the square root of 6. You get the square root of 18, the square root of 36. Now, on this one, you can actually simplify both the numerator and the denominator. The numerator can be split into the square root of 9 times the square root of 2. So that actually becomes positive or negative 3 root 2, while the denominator becomes 6. You could put the positive negative here, but you don't have to because it's already in the numerator. Now we're still not done because 3 over 6 is equivalent to 1/2. So the final step is to actually say 1 root 2 over 2. That's a review of rationalizing and simplifying. Those problems will be on your homework. The second thing that we want to review today is Pythagorean Theorem. So what is the Pythagorean Theorem? If you recall, the Pythagorean Theorem, if I have any right triangle, I would have the short side A, medium side B, and then the hypotenuse is C. The Pythagorean Theorem allows us to find the missing sides of that triangle. And the theorem itself is a squared plus b squared equals c squared. And the positioning of the sides is actually very important. The a and b, not so much, but those need to be the shorter sides. C has to be the hypotenuse, or the longer side, or the one across from the 90-degree angle. So let's do an example. Here's the 90-degree angle. So the one directly across, this is your hypotenuse, which is C. 6 and 8 don't have to be in order because I could write this as 6 squared plus 8 squared equals C squared, or I can write this as 8 squared plus 6 squared equals C squared, and I'm going to get the same answer because addition is commutative. I can switch those around and it doesn't make a difference. So now we're going to simplify and solve. So we get 36 plus 64 equals C squared. Combine your left side. You get, what do you get? 100 equals C squared. I don't know why I'm writing C squared. I should have written X squared because that's the variable here. But does it actually matter? No. Then to get rid of the square root, you take the square root of both sides. And you get the square root of 100, which is positive or negative 10. Now let's think about that answer for right now. You have positive 10 or negative 10. Now you're doing a side length. So which one actually makes sense? Can you have a negative 10 side length? No. So really your answer is just the positive version of 10 inches. You can just ignore the negative option. Let's do number 3. Actually, no, let's do number 4 together, and then you're going to pause the video and do 3 and 5 on your own. So number 4, here's my right triangle directly across. Here's my hypotenuse, so that's C. So if I go and write this in, I'm going to get x squared plus 9.2 squared equals 14.2 squared. And this one, our solving is going to be a little bit different because our variable is on the left side instead of on the right side. So let's simplify. X squared plus, and I'm going to type in 9.2 squared in my calculator, and I get 84.64. And then 14.2 squared is 201.64. Now, to get x isolated, I need to subtract the 84.64 from both sides. And I get left with x squared equals 117. Now, when I go and take the square root of that, unfortunately, the square root of 116 doesn't really simplify. Okay, it gives me 3 root 13, which, do you know how long 3 root 13 is? I don't. So I'm going to use that switch key, and I'm going to convert that to the decimal of 10.8 inches because that's the number that makes the most sense to me. Notice I'm ignoring the negative option because there's no such thing as negative length. So pause the video, do 3 and 5. Now let's check your work. So for number 3, you should have gotten x equals 12 kilometers. And number 5, you should have gotten x equals 7.8 centimeters. Okay. Now to 6 and 7, really these are just more example problems. Number 7, I'm not going to do with you, but I will tell you that the final answer is 16.6 centimeters. So you're going to want to do that one on your own. Number 6, let's talk about, because of this radical side, what happens to our equation when we do that. So again, my hypotenuse directly across from the right angle is C. So I get 11 squared plus the square root of 65 squared equals x squared. 11 squared is 121. Now when I put in the square root of 65 squared, what happens is these two, the radical plus the exponent, just cancel each other out. So that's just going to become our regular 65. 121 plus 65 becomes 186. Now take the square root of both sides and you get 13.6 centimeters. Okay, last type of review, bear with me here, is 8, 9, and 10. These are word problems. Don't let them scare you. Just go through piece by piece. And most important, okay, draw yourself this note up here, important. Draw pictures. As we go through this trig unit, drawing pictures is so important to you understanding these problems and what you are being asked to do. So let's read through this first one. If you remember, we also have our word problem box that I introduced to you way long ago. So actually, I'm going to draw a giant one down here so I can review that reading strategy for you. So we list what we know and what we need. And then we do the work. Okay, so if I read through this, Carl walked 4 meters west, 5 meters south. Calculate how far he is walking from the starting point. So what do we know? We know that he went 5 meters west and, 4 meters west and 5 meters south. Oh man, okay, so if I draw myself a little compass, I've got north, south, east, and west. What's the acronym? Never eat soggy wheat. I think that's how I remembered, or how I learned it. So let's draw ourselves a picture. Okay, here's Carl. Yay, Carl. Okay, he is going 4 meters west, and then he's going 5 meters south. All right, so that's what we know. So what do we need? We need to know how far from the start. And I apparently can't write. The start. So if I look at the picture, if here's where Carl started, I need to find that distance right there. And if this is a 90-degree angle, that means that that x is my hypotenuse. So let's use the Pythagorean Theorem. 4 squared plus 5 squared equals x squared. 16 plus 25, we end up with 41. Square root of 41 is something. So let's convert it to a decimal so it makes sense to us. And it is about 6.4 meters. So how far did Carl walk? Carl is 6.4 meters away from where he started. Okay, so let's do that process for our other two word problems. Word problems are going to be a huge part of this trig unit. Okay, let's go ahead and draw our box. If you don't need this box, I'm not going to make you do it, but it really is helpful. So a ladder is standing on a horizontal ground, rests against a vertical wall. So let's go ahead and draw that part. Horizontal ground, vertical wall. The ladder is 5.5 meters long. And it is 3 feet away from the wall. So here's my ladder. Let's propped up against the wall. How far away is it? 3 feet. And how long is the ladder? 5.5. Okay, calculate how far up the wall the ladder will reach. So how far up the wall? So there's my x. And give your correct answer to 2 decimal places. You want to read those little things because those are the things that trick you up on Math Excel because we have to be precise. So if I find my right angle directly across, here's my hypotenuse. So this is not going to be 3 squared plus 5.5 squared, which is a super common mistake because we just want to assume x is c, but that is not correct because 5.5 is our hypotenuse. So the equation that we actually have is 3 squared plus x squared equals 5.5 squared. So we're going to get 9 plus x squared equals 30.25. Subtract 9. And we get x squared equals 21.25. And now we need to take the square root of that. And we get x equals 4.6 meters. So the ladder is 4.6 meters up the wall. Okay, last word problem here. We've got a soccer field. What do I know? I know we've got a soccer field. Okay, so we've got a soccer field that is 90 by 120. Okay, and the coach asked the players to run from one corner to the other corner diagonally. What is the distance of that diagonal? Let's draw a picture. Here's my soccer field. I know it's 90 by 120, and I want the diagonal. Okay, find your right angle. What's directly across? So that's C. So I get a squared plus b squared equals c squared. So you've got 90 squared plus 120 squared equals x squared. 90 squared is 8100. 120 squared is 14,400 equals x squared. Big numbers, but don't worry, you've got a calculator. If you don't have a handheld one, you've got Desmos. And you end up with x equaling 150 meters. So the final answer would be the diagonal distance is 150 meters. Okay, that's it for notes today. Now you're going to want to go onto Math Excel and complete assignment 8.1.